how are you doing? I'm down at Waddington Europe, formerly Hotwell Plastics here, with one of my best customers who's holding the camera kindly for me here at the moment. The logic of what we're doing here today is to explain about free cooling. Some of you will have seen my vlog I've done from the Central Bank of Ireland, where we have free cooling built into the chillers. This is the other possible way of doing it, where we have a chiller and a dryer cooler upstream. So the dryer cooler does the free cooling first, and then the water, if it's cooled, it's satisfied, the chillers stay off automatically. If it's not, the chillers kick in automatically and make up the balance of the load. So I'll just show you around here just to give you an idea how it's all installed. So this is an Airmec NRB chiller, NRB 1000. So I think it was about 300-400 kilowatts of recollection. So we connected this up to an old chiller that was here. It made sense just to keep it on the loop. Even though the new chiller is more efficient, there's no logic in not utilising it. It's there as a backup. Okay, so with this system design, we have the load, which is the warm water coming back from the factory. So just see the sun is behind me there, so if you just step over there a bit. Okay, so we can see the load is basically coming back here from the factory. That's the warm water. Comes down into a buffer tank. So we're into the warm side of the tank here. We then come out of the tank through a three-way valve. And then this valve, dependent on the ambient temperature and the chill water set point, will determine if the ambient is low enough and we can avail of free cooling. The water is diverted up, as you can see, through this big dryer cooler we have here. That basically comes back down, up there, back down here, and on down then through the two chillers which are connected in parallel. We're then coming back off the chillers into the cold side of the tank, and we have a secondary loop with our secondary pumps pumping back into the factory. So very simple, very straightforward, but we can design this in a way that we can give much more free cooling than with a chiller with an integral free cooling coil. And the reason being simply size. With a chiller that has an integral free cooling coil, we're limited very much by the size of the coil, and consequently the ambient typically has to be a lot lower to get much more free cooling. Whereas with this system we can select with our software whatever size we want, so we can give 100% free cooling at a much higher ambient temperature. So basically, if you have space available, we can give a lot more free cooling. So that's it. Hopefully you got something from that. Thank you.